and that is Serge Andres from Saika Paper Mills in France. Serge, are you there?
Yes, I'm here. Yes.
Can you explain your 2 slides, please?
Yes. Firstly, a short introduction to Saika. Saika is a Spanish family-owned containerboard and cardboard producer located in Zaragoza. The company is running 10 paper machines and about 50 board factories in Western Europe, and the paper mills are working with 100% recycled fibers and have an annual output of about 3 million tons a year. So what did we achieve in SPOTVIEW? You know, or you maybe know that modern paper mills already operate with highly integrated heat and water management systems, and processed waters are already highly reused before disposed of after cleaning. Nevertheless, SPOTVIEW project demonstrated the potential of additional circuit closure via extensive reuse of clarified water completed with heat and valuable substances recovery processes. This additional step in closure is possible thanks to, first, the design of a high flow kidney loop, which purpose is to release out to wash out the released organics and dissolved calcium, and then we can recycle up to 80% of the clarified water in high flows of several hundreds cubic meters an hour with advantages and limited drawbacks. And secondly, with a stepwise replacement of fresh water by clarified water, like cooked starch dilution or chemical dilutions or wet and showers or even floor cleaning. So thus we showed that up to 20% of the fresh water can be substituted, and this represents tens of cubic meters an hour in a paper mill. But the sustainability of this new water system rearrangements requires the implementation of additional processes for heat recovery, valuable substances recovery, suspended solid separation, and sodium and chloride desalination. On the lower side of a slide, there's a rough schematic showing the core process of paper production from recovered waste paper. This is in brown, light brown, the main line, and this core process is completed with the additional clarified water streams we boost in green. Maybe next slide, Hank. So what are the opportunities and the challenges we face? The opportunities with such a new design is to either improve the quality of a paper in a steady scenario, or keep the quality while closing the circuits. In the pulp, we find a lot of detrimental substances, organics, salts, and when we close the loops, when we close the circuits, all these substances remain in the paper, and when we dry the paper, then we usually are facing loss of paper properties. So thanks to a cleaning loop, we can expect either keeping or improving the properties of the papers. Another advantage of such a loop is the reduction in machine shutdown time for cleaning and web breaks. In the pulp, we can find a lot of small contaminants like salts, adhesives, rest of adhesives, and so on. And when using such a loop, an additional loop, all these adhesives, inks, and so on are washed out, and this avoids deposits on the paper machine, wet part, but mainly on the drier part of the machine where the paper is dried, and avoiding thus web breaks and shutdown time. Another point is the reduction in water dependency. We have seen last years that we are really dependent on water due to the droughts we faced. So this is a need for us for our sustainable production of paper to reduce the dependency of water to water. And overall, big challenges for paper mills over the world in general is a reduction of needed heat and reduction of water. So the additional opportunity is improvement of our water footprint. What are the challenges? We still have a lot of challenges. One of them is the recovery of heat in low temperature streams. Our needs are between 60 to 100 degrees Celsius heat streams, but our effluents are as low as 30 to 40 degrees Celsius, and all these streams are huge streams but of low temperature, and we have to check how we can gain again the calories of these low temperature streams. Another challenge when closing further the loops is the increasing amount of highly soluble ions like sodium, chloride or sulfates. These are detrimental to paper production, may lead to corrosion and so on, and decrease the performance of the chemical additives we are using at the wet end part of a machine. So this needs further R&D work, because we already could get rid of such kind of salts, but at high cost, because we have to deal with very high volumes. Additional freshwater reductions is requiring implementation of additional filtering technologies like membrane or technologies or dissolved air technologies, and this has to be cost effective, because we are dealing, as I already explained, with several hundreds of cubic meters of an hour. So it becomes very costly quickly. And then circuits we mentioned, due to the scattered use of the waters in a paper mill, is quite difficult in an existing mill and costly, and is far less expensive in new mills under constructions.
Okay, thank you for this extensive explanation of the opportunities and challenges. One question only. Did the SPOTVIEW project bring you what you anticipated?
There are two different opinions. From the water closure point of view, yes, we could demonstrate that there are still room for improvements, and with new knowledge about what will happen when we close the loops, with the benefits and even the drawbacks we have to face. So from this point of view, the goal is achieved. But on the other side, we expect it to extract valuable substances and to reuse them as a second-hand raw material. And we learned a lot, but at the end, it was really difficult to extract these substances, mainly starch. We have a lot of starch from the waste papers. Roughly about 10% of recovered cardboard is built of starch, with starch. So we expected a partial recovery of the starch, but this was really difficult. The yields were lower than expected. We had to face volatility in the colloidal part of the starch. We couldn't explain why this colloidal part of starch is changing, is fluctuating, and at the end, the recovered starch by itself was a mixture of starch and other materials. So the yield was lower than expected, and the resulting product was not really selectively separated. So we learned a lot. There's still additional R&D work, but this was a little bit disappointing.
Okay. Thank you very much.